Hello, math friends. Welcome to A Squared Math and Stuff. This example is going to focus on a regular polygon where we are given the radius of the polygon and we are asked to calculate the area. This 6.6 yards here is the radius because if we were to circumscribe a circle or draw a circle around this octagon, because this is an 8-sided polygon, draw a circle around this polygon, it would touch at every one of these vertices. So this line here is actually the radius of the circle that has the center here. And what we're going to do with this is we are going to look at this regular polygon in terms of triangles. So if you remember from the last example that we did, we were able to divide this regular polygon up into the number of triangles as there are a number of sides. And that's what we're going to do here. So we have this triangle here, and we know the area of a triangle is equal to 1/2 times its base times its height. We don't know the base or the height in this case, but we do know enough information to calculate that using our sine, cosine, and tangent. And we can figure out the angles that we need by working with the fact that we know the central angle, or the angle that comes off the center of our polygon. So we are looking at this angle here, is equal to the number of sides, or 360 divided by the number of sides. So our central angle, is equal to 360 degrees divided by the number of sides, where n represents the number of sides. And that's of our polygon. So in this case, it's 8. So our central angle here, I'm going to symbolize angle like this, is equal to 360 degrees divided by 8, or in our case, our central angle is 45 degrees. So that means we have a 45-degree angle right here. That doesn't help us a whole lot at the moment, but what we can do is we can create a 90-degree angle here so that we end up having a right triangle. If we drop the height of this triangle that we drew, we have this, and anytime we draw the height of a triangle, it's perpendicular to its base. And because we have a regular polygon here, we have created a perpendicular bisector. So we have cut the side length in half, and we have also created an angle bisector. So we have cut this 45-degree angle in half as well. So I'm going to redraw just one of these right triangles down here. Let's take this. I'm going to draw the left-hand side of it. If I take 45 degrees and I divide that in half, take 45 degrees, divide that by 2, we end up with 22.5 degrees. That means we're working with 22.5 degrees right here. We know the radius was 6.6 yards. This radius is now the hypotenuse of this right triangle. So our radius, or our hypotenuse, is still 6.6 yards. And the side opposite of our given angle is our base. This is our opposite side. And the side that's adjacent to our given angle is our height. Let me grab one more color in here. So this is our height. And this is our adjacent side. ADJA. I think I spelled that right. I hope I spelled that right. Otherwise, it's in permanent ink on video that it's wrong. Anyways, now that we have a base and a height, or an opposite and adjacent along with a hypotenuse, we can work with our trig functions. We can work with sine, cosine, and tangent. So the first one I'm going to look for is my base. My base is my opposite side, and I know my hypotenuse. That means that I'm working with opposite and hypotenuse or my sine. So I'll take the sine of 22.5 degrees, and I set it equal to my opposite side length, which is the base, all over the hypotenuse, which is our 6.6. Put this over 1, and we can do our cross multiplication, and we can solve for our base. So we will see that the base is equal to 6.6 times the sine of 22.5 degrees. That means that our base is equal to 2.526 yards. Our answer wants us to round to 2 decimals, so I'm going to round to 3 decimals on all of these numbers that I'm working with, and I'm going to wait till the very end to give my answer in 2 decimals. Otherwise, I'm rounding, and then I'm rounding, and then I'm rounding again, and if you keep rounding, then your answer ends up being a little bit too far off sometimes for your math teacher, and you might get it wrong. So that's just a little piece of advice right there. The next thing we're going to calculate is the height, because we need the height of this in order to calculate the area of the triangle. So we have our base. Let's calculate the height. And in this case, the height is our adjacent. So do you recall what trig function we work with when we're working with the adjacent and the hypotenuse? Good, that's cosine. Excellent. So we're going to take cosine of 22.5 degrees and set that equal to our height, which is the adjacent, and that goes over the hypotenuse of 6.6. Put this over 1 again, do our cross multiplication. Our formula is then our height is equal to 6.6 times the cosine, oh boy, running out of room here, cosine of 22.5 degrees, which when you calculate it out gives us a height of 6.098 yards. All right, so now we have the 2 values that we're looking for. We have our height, we have our base. Let's plug those back into the area of a triangle. So 1/2 base times height. Let's calculate that out. Let's see what the area of this green triangle is. So the area of our green triangle is 1/2 times our base, which is 2.526 yards, and then multiply it by the height of 6.098 yards. Plug that bad boy in your calculator, and you will get 7.702 yards squared. So that's the area of this little triangle here. So that's awesome. We found one triangle. But how many of these little triangles are in this regular polygon that we have here? So we just did this. We calculated one of these. How many of those are there in here? Well, I end up with 8 triangles, right? Because I have 8 sides. But I only looked at half of this triangle. So I actually have to double the number of triangles in here, because I've got 1, 2, then I'll have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's take the 7.702 yards, multiply that by 16, because we have 16 smaller triangles, and we will get 123.23. That's where I round. This is my final answer. I got 2 decimal places. Yards squared. So the area of our, what is that, an octagon? Octagon. Man, I'm terrible at spelling, I'll tell you what. 123 yards. Ooh, squared. Almost forgot that. All right, so recap. We were given regular polygon. We divided it into the smaller triangles, but then we had to drop that height. Using sine and cosine, we figured out the base and the height, plugged those into the area formula for a triangle, and then multiplied it by 2 times the number of sides. Because we only worked with half of that larger triangle that we drew in at first. 2 times the number of sides. So, if you like what you saw, please hit the subscribe button down below, and I will chat with you later.